right, so here we have another example problem. This problem is slightly different in that we have multiple conversions present or that are being asked of us inside of this problem. We are told that one lap around a particular track is 255 meters. The question is, how many laps are there in 10 kilometers? So here again, there are a couple of conversions that we're going to need to put together in order to answer this question. You can either do this calculation one conversion at a time, or what I'm going to demonstrate in a couple of minutes is how we can tack multiple conversion factors together to kind of answer the question in one fell swoop. As previously stated, this example problem will be extracted into a separate video. Also, as previously stated, I would like you to try and pause the video and solve this question yourself. Can you figure out how many laps there are in 10 kilometers, provided that one lap is equal to 255 meters? Assuming that you have paused the video, I'm assuming now is the moment when you have unpaused the video. So welcome back. Let's set up and solve for this problem. Now again, a good approach in solving this type of word problem, where I know, again, if you're more mathematically focused, if you're more mathematically skilled, this you probably don't even have to think about. But for those of you who are apprehensive about math, again, we're just taking this in bite-sized pieces. And there's no shame in doing that, right? You don't need to demonstrate that you can solve this problem in one fell swoop if you're uncomfortable doing so. So let's just break it down piece by piece. It's totally fine. The important thing is that you understand the process. So we're going to first gather the information. We're just going to break this problem down, again, word by word, sentence by sentence, piece by piece. So in the first sentence, we are told one lap is 255 meters. Now mathematically, the is represents an equal sign. That is, in my experience, 99 times out of 100 going to be true. If you see the word is, what this means is that there is an equal sign in a mathematics statement. The left-hand side, we are told that one lap is 255 meters. And here now, it appears as though we have the precursor of potentially being able to set up a conversion factor. The question is, which side do we want to divide to the other? Well, that can be answered by the following sentence afterwards. The question is, how many laps are there in 10 kilometers? All right, so we have some distance information pertaining to the meter. It's not exactly a meter. We have a kilometer. We have, well, the unit of the kilometer. Specifically, we have 10 kilometers. But 10 kilometers can be pretty easily translated or converted into the meter, because we know just from, metric conversion standards that there are 1,000 meters inside of a kilometer. All right, so if we're trying to figure out how many meters there are in a kilometer, so that way we can figure out how many laps there are in a meter, it appears as though the first conversion we are going to want to get out of the unit of the kilometer and into the unit of the meter. What this means is that we're going to want to make sure that kilometers are in the denominator of our conversion factor, right? We're trying to get out of the kilometer and into the meter, so that way we can answer how many laps there are in that meter and actually solve the problem. So we're trying to get out of the kilometer. We're going to put that unit of the kilometer in the denominator. We're trying to get into the unit of the meter, so we're going to put those 1,000 meters up on top. This will ensure, mathematically again, that our kilometers are going to cancel out. Now, we could just put an equal sign here and say, okay, well, there are 10,000 meters. But as I just said, we can string together multiple conversion factors in order to solve this problem in more of a concise calculation. So instead of just solving for meters and then setting up a second conversion factor for a second separate calculation, let's just set up the conversion factor and tack it right on here, times by. We are currently, at this point, right, you are here in the unit of the meter. So whereas previously we wanted meters in the numerator to get into the meter, now we are in the meter and we want to get out of the unit of the meter. So what this means is our second conversion factor, which is based off of this equivalence here, we are going to want the meters now in the denominator. See, we're currently in the meter. We want these meters to cancel. We want them to be on opposite sides of this divide. There are 255 meters in 1 lap though. And now we can see that we have converted from our initial measurement that was 10 kilometers, and the only unit standing is the lap. So we've been able now to, we just did this. We set up a calculation to answer the question, how many laps, used our conversion factors to specifically convert, leaving only the unit of the lap. So this calculation then, in solving for how many laps there are, we are left with 39.2 laps. All right, so again, the number 10 looks very different than the number 39.2, but if we take into account the fact that we have units associated with these numbers, and along the way, all we've done is multiply by 2 different versions of the number 1, 10 kilometers can assuredly be mathematically true as a statement to be equal to 39.2 laps. All right, hopefully you were able to get the same answer as I did. If you feel more comfortable, again, kind of breaking this type of problem down into 2 smaller problems and you're not comfortable quite yet stringing all of these conversion factors together, totally fine, right? You can solve the problem in whatever way you are the most comfortable solving the problem. You can take as much time as you need on these types of problems since this is a lecture portion. Totally fine.